Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 30, linear systems in 3 variables. Okay, so classwork opening exercise here, exercises 1 through 3. It means you should be able to do these already from Algebra 1. Pause the video. These are systems of equations solving for 2 variables. So pause the video, see if you can do these and come back. Okay, so here we go. Before I get started though, if I have a number in one equation and the same number in the other equation and I subtract them, I get 0. If I have a number in one equation and I have the opposite in the other equation, I add to get 0. So the goal here is to cancel one of the variables so we can solve for the other. All right. So with that being said, these are already all lined up nicely and I see a 2x and a 2x. They're the same. We're going to subtract. So I just draw a line under here. 2x minus 2x is 0x or just 0, and 3y minus y. So what I'm doing here is subtracting because they're the same. So I put a minus sign out in front and it probably wouldn't hurt to put a parentheses around it. You're subtracting everything. And 3y minus y is 2y. 7 minus 3 is 4. Divide both sides by 2 and we get y equals 2. Now we go back and substitute our y in to our equation. And one of our equations, it doesn't matter which, it's got to be true for both. So if I take 2x plus 3y and set it equal to 7, that's the first equation. And now I know my y is 2, then it's going to be 2x plus 3 times 2 has to equal 7. Okay? And simplifying, we get 2x plus 6 equals 7. Subtract 6 over to the other side and 2x equals 1. Divide both sides by 2 and we get x equals 1/2. Okay, so you can say x equals 1/2, y equals 2, or you could write them as an ordered pair, 1/2, comma 2, because they are linear equations in standard form. And if they intersect, that's the solution set to this system. They will intersect at x equals 1/2 and y equals 2 on the coordinate plane. Okay, number 2. 5x minus 2y equals 4. So I look and I see a 5x, I see a 2x. They aren't the same or opposite. I see a negative 2y, I see a positive y. I don't see any equal or opposites there either. So in this situation, we need to do a multiple. So I'm going to take this second one and I need to get opposites. So 2 won't go into 5, obviously. So if I only want to do as little as possible to solve this, multiplying y times 2 would give me the opposite of negative 2. So I'm going to multiply this second equation by 2. So what's that going to yield? So I'm going to arrow over here. 5x minus 2y equals 4 did not change. But I'm going to take 2 times a negative 2x, and that's going to be negative 4x. 2 times y is 2y, and 2 times 2 is 4. So now you can see I have opposites. Great. All right, so now this is messed up. What's going on? Momento. Okay, sorry about that. My virus scanner messed me up. So here's our opposites. We have a negative 2y and a positive 2y. And I'm going to add because they're the opposite. So 5x plus a negative 4x is 1x. Negative 2y plus 2y is 0, so it cancels. And 4 plus 4 equals 8. So I suppose I should put a plus sign out here just so we remember what we're doing. And so we get x equals 8. Okay, I usually just take the first equation and use that. It doesn't matter. So 5x minus 2y equals 4. 5x minus 2y equals 4. 40 minus 2y equals 4. And subtract 40 over to the other side, I get negative 2y equals negative 36. Divide both sides by negative 2, and I get y equals 18. Okay, and then the last problem I didn't check, but you should always check. So I will check on this one. So I'll do it in the other just to check. So I'll say negative 4 times my x plus 2 times my y, right? This comes from here, and this is coming from here, has to equal 4. Well, 8 times 4 is 32. Positive times a negative is negative, negative 32. 18 times 2 is 36. And 36 minus 32 is 4, so it checks. So I like putting my answers in ordered pairs because it is a system of linear equations, and my answer is x equals 8 and y equals 18. I almost used my checked value. So x is 8, y is 18. So there's number 2. All right, page 2 brings us to exercise 3. A scientist wants to create a 120 milliliter of solution that is 30% acidic. So they want to create this. To create the solution, she has access to a 20% solution and a 45% solution. How many milliliters of each solution should she combine to create the 30% solution? Okay, so how many milliliters of each? So there's all the information right there. Well, we have 120 milliliters of solution. All right, so what we do is we will call this solution X, and we'll call this solution, solution Y. So given a total, just starting with the easy part, there's some amount of the first solution plus some amount of the second solution is going to equal our total solution of 120 milliliters. So first we're talking about the volume, and then next we want to take into consideration the percentages of each. So this is going to be our leading coefficient for each of these variables. So I need a 20% solution of X plus a 45% solution of Y, and I want 30% of 120. Okay, so 30% of 120 is going to be 120 divided by 0.30. Okay, 3 goes into 12 for what? Hang on. What am I doing? Okay, I'm not dividing. Percent is a decimal. So 30% as a decimal is 0.30. So 30% of 120 is 0.3 times 120, and that is going to equal 36. So that is going to be my total. 36 is 30% of 120. So now I have these two equations. The x's do not match, and they're not opposite. The y's do not match, and they're not opposite. So I could multiply the top by 0.2 to get rid of the x. I could multiply the top by 0.45 to get rid of the y, or I could multiply the bottom by 5 to get rid of the 2o, or I could multiply the bottom by something to get rid of that 0.45. And we usually try to choose the easiest one. Well, 20 will go into 120. So if I will simplify this total and get rid of x at the same time. So if I focus on this top and multiply it by 0.20, and you're doing the whole thing, so I got parentheses around the whole thing, then we're going to end up with this. Distribute 0.20x plus distribute 0.20y equals distribute 0.2 times 12 is 60, or 0.2 times 12 is 6, and then the 0. So 20% of 120 is 60. Is that right? No, that's not right. It's not 60. That's half. Multiplying. 2 times 0 is 0. 2 times 2 is 4. 2 times 1 is 2. Hello. All right. 20% of 120 is 24. Made the same mistake as I was doing over here. All right. So anyway, so we have 0.20x plus 0.20y equals 24. And then bring down our other equation with no changes. 0.20x plus 0.45y equals 36. All right. So now we have this opposite or the same. So we're going to subtract. So this is going to cancel. 20 minus 45 is a negative 0.25y equals 24 minus 36 is a negative 12. Divide both sides by a negative 0.25 and we'll find y. Okay, so there's, think of this as quarters. There's 4 quarters in $1. There's 4 quarters in 1. So 4 times 12 is 48. So y equals 48. Okay, and now we have to find x. So it'd be easier to go to our original equation, x plus y equals 120. X plus our substitution of the y we found equals 120. And we're going to subtract. Whoops, x plus 48 equals 120. Subtract the 48. Okay, and that cancels, and I get x equals, that's 2, and that's 7. So x equals 72. So my answer is 72, 48. What does that mean? I want 72 milliliters of my 20% solution, 48 milliliters of my 45% solution. That will give me a 30% acidic solution that totals 120 milliliters. All right, page 3, I think. Yes, page 3 brings us to this first example. So what we're going to do is we're going to determine the value for x, y, and z in the following system. Remember, this lesson is 3 variables. So the first thing I will do is I will focus on the first 2 equations. So I'm going to just rewrite. So I'm going to name this equation 1 and this equation 2. And this equation 3. Okay, so I'm going to take 1 and 2, and I'm going to get rid of z in those. So here is the combination of 1 and 2. All right, so we're going to keep track of these. So I'm going to take 2x plus 3y minus z equals 5. Now I notice that they have a minus z in each of them. If I add them, I get minus 2z. If I subtract them, then I will get rid of the z. So I'm going to subtract 4x minus y minus z equals negative 1 from the first equation. 2x minus 4x is a negative 2x. 3y minus a negative is plus. 3y plus y is 4y. Negative z minus a negative z is plus z. Negative z plus z cancels, and I get 5 minus a negative 1, which is 5 plus 1, or 6. So now I have negative 2x plus 4y equals 6. That was from combining 1 and 2 and getting rid of z. So now I'm going to go and I'm going to take these 2. I'm going to take equation 2 and equation 3, okay? So those 2 are going to be 4x minus y minus z equals negative 1, just like it did here. And then I look at these, and these are opposites. So I'm going to just simply add these 2, and I'm going to add x plus 4y plus z equals 12. So when I add those, I get 4x plus x is 5x. 5x. Negative y plus 4y equals 3y. Negative z plus a positive z is 0, and they equal negative 1 plus 12, or 11. Okay, so now I have two equations, and there are no z's. Now we're down to two variables, x and y. Okay, so now I'm going to take the new equation that we got from combining 1 and 2, and the new equation that we got by combining 2 and 3. And we are going to manipulate one of them so that, or both of them possibly, so that they're opposites. So we could either get rid of the x and solve for y, or get rid of the y's and solve for x. It doesn't matter. So I will get rid of the x's. So if I take negative 2x plus 4y equals 6, and right underneath it put 5x plus 3y equals 11. I look, I don't have any values that are opposite or it's the same for my x coefficient. 4 and 3 are not opposite or the same. So I'm going to now multiply this first one by this first number 5, and I'm going to multiply the second equation by this negative 2, because that's going to give us the same x values, and we can then subtract and get rid of them. So this is going to yield two new equations, and I'm going to distribute. 5 times negative 2x is negative 10x. 5 times 4y is 20y. 5 times 6 is 30. Okay, very simple distribution. Now I distribute this. Negative 2 times a positive 5x is negative 10x. Negative 2 times a positive 3 is negative 6y. Negative 2 times a positive 11 is negative 22. Now I have my x's equal. So if I subtract them, I'll put a minus sign there. Negative minus a negative is plus. These will cancel, give me 0. 20 minus a negative is plus. That'll give me 26y. 30 minus a negative 22 will give me 52. Divide both sides by 26, and we get y equals 2. Okay, so we found y. Now we can find x. In order to find x, we just pick one of these two equations that we've already simplified. I will use the 5x plus 3y equals 11, and I'll put 2 in for y. So it's going to be 5x plus 3 times 2, and that came from here, by the way, so I'll just do this. There's my y, see the y right here, and that is going to equal 11. 5x plus 6 equals 11. Subtract 6 to the other side, 5x equals 5, and therefore divide both sides by 5 will give us x equals, yeah, 5 divided by 5, 5. No, 5 divided by 5 is 1. Okay, so I am going to get an answer. Oh, let's just wait. Let's finish before I do that. So what do we have? We have x equals 1. We have x equals 1. We have y equals 2. We don't know z, but all we have to do is take one of these three equations, it doesn't matter which one, and we solve for z. So I'm going to use the first one. I'll use equation number 1. And again, like I said, it doesn't matter. So equation 1 is 2x plus 3y minus z equals 5. X is 1, so it'll be 2 times 1 plus 3 times y, which is 2, minus z equals 5. 2 plus 6 minus z equals 5. 8 minus z equals 5. Subtract 8 to the other side, negative z equals negative 3. Multiply both sides by negative 1, z equals 3. So we get the ordered pair, or the set. Yeah, it's still an ordered pair. instead of x comma y, it's going to be x comma y comma z. So x is 1, y is 2, and z is 3. Okay, and I'm still not confident. I shouldn't say confident. I'm confident, but I'm still not convinced that this is true. So now I'm going to check my solution in number 3. So x is 1. 1 plus, right here, x is 1. 1 plus 4 times y, 1 plus 4 times y, plus z equals this 12 right here, 12. 1 plus 8 plus 3 has to equal 12. 1 plus 8 is 9, plus 3 is 12. 12 does equal 12, and it checks. So this is my solution. X equals 1, y equals 2, and z equals 3. Okay, page 4 brings us to exercise 4 and 5. You should be able to do these on your own now that I've done an example. So pause the video, see if you can figure these out, and then come back and check. So here we go. So it says, given the system below, determine the values of R, S, and U that satisfy all 3 equations. Well, I see an R here, I see an X, a U, an S, a U, an R, an S, a U. So there's a problem right here with this first one. We have another variable X and nothing else has an X in it. So I'm going to number these 1, 2, and 3. So since there's no X's in these last two, I'm going to focus on combining 2 and 3. Okay, so 2 is S plus U equals 4. 3 is R minus S minus U equals 2. When I combine those, I'm going to add because we have opposites, and when you have opposites, you add. So it's going to be 0 plus R, which is R. S minus S, or plus a negative S, is 0. U plus a negative U, there should be a plus here, is 0. And 4 plus 2 is 6. So right off the bat, we're just left with R equals 6. So I'll just write that over here, and I will put it this way. So this is R, this is S, and this is U. Okay, so we found R, 6. Now I'm going to take that 6 for R and substitute it in to 1. And now we'll work with this and this. Okay, so let's see. Yeah. Okay, hold the fort. This is a misprint in the student edition. In the teacher edition, it is an S. Okay, there is no X in this. Okay, we're not working with 4 variables yet. That is an S. All right, my fault. So we are going to plug that 6 in there, and we're going to then do number 1 and number 2. Okay, so this is going to be a combination of 1 and 2, and 1 is 6 plus 2S minus U equals 8. 2 is S plus U equals 4. Okay, so I have opposites here. You add opposites to cancel. 6 plus 0, so we're adding. 6 plus 0, let me change this. We're adding. 6 plus 0 is 6. 2S plus S is 3S. Negative U plus a positive U is 0. 8 plus 4 is 12. Subtract 6 over to the other side. 3S equals 6. Divide both sides by 3, and we get S to equal 2. So I'll put that right here. So now we have R, we have S. Now we just need U. So how about we just choose 2 to find U? That's the easiest way. So we have s plus, whoops, we have s plus u equals 4. S is 2. We don't know u, and that equals 4. Subtract 2, and u equals 2. Okay? So we put a 2 up here, and we have r is 6, s is 2, and u is 2. Let's check it in 3. So here's our check down here. So I'm going to take r, 6, minus s, 2, minus u, 2, equals 2. Well, 6 minus 2 is 4. 4 minus 2 is 2. And yes, 2 does equal 2. And it checks. So here is the answer to that. And I don't know, the electronic version has an X. I don't know if yours does or not, but it should be an S as in Sam, not X as in X-ray. Okay, this one might be a little bit tricky. This one you might have had some trouble getting started. And if you can't start, you can't finish, right? All right, so here's this trick. This is X in this point, and this is Y. This is an X, this is a Y. Let me use different colors. Okay, bear with me here a moment. I'm just labeling all of these. These are X's and Y's. This is an X, this is a Y. We have a Y, we have X's. We have A, B's, and C's. So I'm going to first start off with my first point that's in red and let X equals 1 and let Y equals 6. So if I take Y equals AX squared plus BX plus C, and I substitute my givens, Y is 6 equals A times X, which is 1 squared, plus B times X, which is 1, plus C. So 6 is going to equal 1 squared, which is 1, times A is simply A. B times 1 is B, and C is just C. So I have an equation, 6 equals A plus B plus C. I'm now going to do that again. Y equals AX squared plus BX plus C. Now Y is 20, so I'll put a 20 here. Now my X is 3, so I'm going to put a 3 here, squared, plus B times 3 plus C. So this is going to come out to be 20 equals 3 squared is 9, so I have 9A, plus 3 times B, or 3B, plus C. All right, you getting the idea now? And then the last one, Y equals AX squared plus BX plus C. Y is 15. X is -2. Be careful with that negative. When squaring, it won't be. And B times -2 plus C. This is going to give me 15 equals. -2 squared is +4. Careful there. -2 times B is a -B or minus, or -2B or -2B plus C. So now I have 3 equations with A, B, and C in them. And now if I just work at solving for one of them and eliminating another variable, then we can break it down like we did before. So let's call this equation 1, call this equation 2, and call this one over here equation 3. So I'm looking, I guess I'll do the first two. This avoid negatives when you can, and these ones will make it very easy. So I'm going to combine 1 and 2. Okay, so that's going to give me 6 equals A plus B plus C, and 20 equals 9A plus 3B plus C. Notice I have 2 that are the same. When that happens, we're going to subtract, minus everything. So when I do that, I'm going to 6 minus 20, -14. 1 minus 9, 8. B, 1b minus 3b is negative 2b. C minus c is 0. So now I have an equation in just terms of a and b, and I'm now going to look at equation 2 and 3 and do the same thing. So here I will do 2 and 3. Alrighty, so in doing that, we have 20 equals 9a plus 3b plus c. And the blue one, we have 15 equals 4a minus 2b plus c. When I do that, I have 2 plus c's. Again, I'm going to subtract. 20 minus 15 is 5. 9 minus 4 is 5a. 3 minus a negative 2 is plus 2. 3 plus 2 is 5b. And c minus c is nothing. We got rid of our c's. Okay, so we have negative 14 equals negative 8a minus 2b, and 5 equals 5a plus 5b. Okay, hopefully you remember what to do now. We take these two equations and put them together, and we multiply by something that will cancel a or b. So I'm going to write, let's use purple, just so we can see the difference. Negative 14 equals negative 8a minus 2b. And 5 equals 5a plus 5b. 2 and 5 are not the same or opposite. 8 and 5 are not the same or opposite. So I'm going to do multiples of each. And I am going to multiply by, we can either do these two and get rid of the a, or we can do these two and get rid of the b. I will go with a smaller value since 2 is smaller than 8. I will multiply. So we're focusing on getting rid of b. So I'll multiply the top one by b's coefficient down here, and take this coefficient and put it down to this one. And that will yield 2 new equations. And 5 times 4 is 20, carry the 2, 5, 6, 7. 5 times negative 14 is negative 70. I'm distributing. 5 times a negative 8 is negative 40a. And 5 times a negative 2 is negative 10. Whoops, negative 10b. All right, now when I distribute this, I get negative 10 equals negative times positive is negative. 2 times 5 is 10a. Negative times a positive is negative. 2 times 5 is 10b. So now that I have two equations and they're the same, we are going to subtract. Okay, negative 70 minus a negative 10 is plus 10, so it's negative 60. Negative 40 minus negative is plus 10 is negative 30a. Negative 10 minus a negative is plus, negative 10 plus 10, b's cancel. Divide both sides by negative 30 and we get a. Negative divided by a negative is positive. 60 divided by 30 is 2. So I'll put my answer over here when I'm done, being A, B, and C. And I know A is 2. So we got the first one. Okay, so now I can just take and substitute in my 2 into one of these two equations to get B. I will do it from this one right here. So it's going to be 5 equals 5 times A plus 5B. 5 equals 10 plus 5B. All right, let's try it again. That is a B. All right, so that's going to be 5, negative 5, because I'm subtracting 10 over the other side. Negative 5 equals 5B. Divide both sides by 5, so I get B equals negative 1. So I put a negative 1 here. Finally, we're going to come over and we're going to use 3 again. And we're going to substitute in our A and our B and find C. So 15 equals 4 A minus 2 times B plus C. 15 equals 8. Negative times a negative is positive 2 plus C. 15 equals 10 plus C. So therefore, subtracting 10, C equals 5. So we got 2, -1, and 5. Okay, push the wrong button there. Hope there's not much of a delay. So I've got my A, I've got my B, I've got my C. It says find the equation in the form. So now we just have to say the answer, and I'm going to put it right here. Y equals AX squared plus BX plus C. So my answer is the parabola or the quadratic y equals 2x squared minus x plus 5. I don't need that one there, but you know what I'm talking about. Okay, so these 3 points would land on that parabola. Okay, page 5 brings us to the end of lesson 30. Go to your problem set.